I'm saying science, okay? Today's experiment is rates of reaction, okay? So we haven't studied this yet. We will do it, but it's just an interesting experiment. So things you need are materials is a glass. So I have a glass here, all the same glasses. Weight to measure 50 to 100 centimeters cubed of H2O. So I'm using just the normal balance. Okay, so there, that's only just about 100 grams because never mind. Dissolving tablets that react with H2O, which means like these things. Okay, so that's what I'm using here. The multivitamins, and to save time, I've broken them into halves. Okay, you don't need to have a full one. You can do half ones, or you can do a full one if you want. It's up to you. Okay. I need water, so I need water and something to crush up the tablet. So I have one tablet, half a tablet crushed here. Okay, so I used my spoon earlier on, and I just crushed it in. Okay, so we'll see what happens there. So what's going to happen really is you're going to have 4 half tablets or 4 tablets. Your H2O cold, so I have water in the fridge. A H2O room temperature, so I have water over here somewhere. I have 2 glasses of water. I have H2O room temperature is there. H2O hot, the kettle is on, and H2O room temperature again with powdered. Okay, so you're doing 4 times 4 procedures. So what you do is weigh out 100 grams of room temperature water into a glass. Okay, so I'll use this one over here. I'll take that. It's been there for a while, so it's room temperature. It says my room temperature. Okay, I get my stop clock ready. I have my tablet ready. Next one is add the tablet half a full, but keep it the same. So they're all the same. Okay, give or take. So I put it into the water. Press start, and you simply watch. Okay, so we're watching for a reaction. So the reaction is happening already. There's a gas being given off. Okay, so it's a very simple reaction. You've probably seen this all the time. So we're just going to investigate what conditions make it react faster. Okay, I did actually use this in a previous experiment, but it doesn't go below 33.3 degrees. Okay, so very useless. The hard part here for you is to be very subjective. When is the reaction over? Okay, so when you think the reaction is over, keep it to the same for all of it. Okay, and you'll see here what I mean. Okay, so it's nearly there, still dissolving away. I don't want to stir it or shake it by just moving it small bit. Okay, I don't want to add any more energy to it. So this is the exciting part. Still a small bit left there. We're at 52 seconds. Okay, that's 1 minute. I'm going to call it in a couple more seconds because I don't want to spend too long either. Okay, so I'm going to stop it there. Okay, and I have 1 minute and 7. So it's nearly over, and I'll use that same one. So it's nearly over. So go over to my worksheet over here, which I've drawn out. Here's our table. Up here we have water type, room temperature, RT, cold temperature, CT, hot temperature, HT, and room temperature with crushed. Okay, so in a lab we would actually measure the proper temperature degrees, but I can't here. So this was normal room temperature. 107 is 67.86 seconds. Okay, cool. So as you can see, it's close enough. It's about, I did it twice already just to practice it. It's about 66 seconds, okay? 66.0 seconds. That's good. Okay, the next one we'll do is cold temperature. So we'll go up to the fridge. Okay, I have it in the fridge for a while. You don't need to see what's in my fridge. So here's cold water. You just have to take my word that it's cold water. Okay, so it's cold water. It's been in my fridge for about, I don't know, half an hour to an hour. Here's a tablet. I have my phone ready. Okay, I put it in. Start. It's running. And straight away, you can see it's reacting. It's reacting quite well. Okay, it's colder water, so I would expect it to react slower because there's less energy in the water. So we talked about energy before in the water. Less energy means the particles aren't bouncing around as much, so the reaction should be slower, but it looks quite quick. Okay, we're at 27 seconds. So it's basically, I said I can probably end up doing it in high school, so whoever stays next year will probably do it in high school. We did in the lab with different chemicals. You did it already once, I think. We did something similar where you had a delivery tube, you put in some HCl, which is an acid, into some metal. So the whole theory is what would happen if I put in a very strong acid, or what happens if I put in a metal like crushed up, okay? Would the reaction be different? So it still is reacting, it's still quite slow. I'm waiting for a tablet to come up. Yeah, it just popped up. Okay, it's over to the side. Still a bit of a chunk there, and I'm not going to call it yet. It's still reacting away. That's good, I can still hear it, so you know its chemical reaction is happening. There's bubbling, there's a sound off it. It's still there, still hanging in there. Okay. Right, and I'm gonna, it's at 1 minute 30, so I'm gonna stop it there, okay, 1 minute 30. So, don't spend too long, so 1 minute 30. So over here, cold water, CT, 1 minute 30 is 90 seconds again. Okay, so that's a nice average, 90 seconds. Okay, the next one will be hot water. Just press that here. As you can see, that's the reaction, so that's happening. One more tablet here. I have another glass. These are all exact same glasses, so please have the same glasses if possible, same amount of water, all 100 grams. So I'll do 100 grams in here. I have the kettle has been boiled, so please be careful. Get your mommy or daddy to do it if you need to. That's there. So I'm going to try and get as close to 100 as I can. Now it is spilling, unfortunately. There. It's a 99, that's okay. 104, okay, that doesn't matter. Doesn't matter. 100, 104. It's not going to make a huge difference in this experiment. Okay, so last part, I have my clock again. I have my tablet. I press start and put it in. So as you can see, it's a huge difference. Okay, it's reacting a lot quicker than the other ones. Okay, there's a lot more gas being given off. You hear the sound, you can hear the effervescence. Okay, so it's a nice chemical reaction. Okay, I'm going to call it there. Okay, so it's 27.70. I did it earlier, I got 27.5, so that's good. So my averages are quite okay. So I'm doing okay. And it's an average of 27.0 seconds. Okay, good. That's a seconds. It's hard to write this way. Okay, the last one we'll do is room temperature again. So it's room temperature, it's the same temperature as the previous one. There we go. And this time I have a powder. Okay, I probably should have went through a spoon beforehand. But look, no, I won't bother doing it now. It'll be okay. Okay, ready? I'm just going to hold it up here because I need 2 hands for this one. Ooh, don't fall. 3, 2, 1, go. Okay, so it's reacting very quickly. It's more spread out. So in your conclusion, you will tell me how come this one is reacting so quickly. Okay, so the water isn't very hot, it's the same temperature as the last water. It's still reacting though. This one's hard to tell when it's stopped. Okay, I'm actually going to call that one. Okay, I'm going to call that one, and it is 29. In my previous one I got 38, so that's what's going to make my results a bit different. 29.17. So my average there is about 35, I suppose. 35.0 seconds. Right, there's no calculations, you're happy enough with that. But you will do a bar chart. So you will probably say this with Mr. Law and Maths, I hope, at this stage. If not, you'll do it with me again during the year, maybe next year. It's very simple. You have a bar graph up this axis here, the y-axis, you have time. 100, 90, 80, 70, 60, 50, 40, 30, 20, 10 seconds. And down here, this is a bar chart. I have RT is room temperature. CT is cold temperature. HT up there is hot temperature. And crush, yeah, you can have that. My son just wants it now. So, okay, so crush is the crushed one, okay? So up here, 66 seconds was the room temperature. So up here, 66, 65 is up here. So you make a bar chart. It's all the same width, okay? These all have to be the same width. Okay, so it has to be a gap in between, and they're all 2 centimeters across. The next one is cold temperature, which was 90 seconds. So up here I go to 90 seconds. Up here, I come across, and I make it 90 seconds. Okay. The hot was 27 seconds. So 27 is here, and there's 27. Okay. And the last one was room temperature. I had 38 first, so I used those ones. and 29, so it's 35. So I should go to 35 over here, come across and have 35 here. Okay, then using your bar graph, it'll make it look nice, nice colors, and using your values, I want you to do a conclusion, and your conclusion will be nice and easy. Which was the fastest reaction and why? Which was the slowest reaction and why? What did you expect, and compare it with your answers? So what did you expect would happen? Which would be the fastest? Was it the same as what you expected? And how would you make the experiment even quicker?